Hi, this is part 6 of processing motion. We're going to be talking about oscillatory motion, so things that oscillate. If you get one of these springs from your physics teacher, he or she definitely has one. It's in the storage room somewhere. Dig it out. You hold one end, and either get one of your human friends or even a mechanical friend, some kind of oscillating machine to hold the other end. And if you move that spring back and forth at a steady rate, you'll most likely create a traveling wave, which is the focus of our video today. So first we're going to go over definition of a traveling wave and the equation of a traveling wave, and we'll use the variables that we discover to create a processing sketch to draw one. So let's switch over here. Okay. So, first we need to go over the concept of a wave on a string. Just like with the spring, I mean SP spring, you can also make these waves on a string, ST string. Helps to have some beads on the string, so you can see what's going on a little bit easier and add some mass to it. So suppose you have string and it is beaded, so you have a string of beads, and suppose you go to one end and you kind of disturb it, right? You raise it up. Well, this part of the string is going to respond, and each of these beads will move a little bit. And if you repeat this pattern and you slide that first bead up and then down, up, down in a repetitive fashion, you can set up a traveling wave so that some of the beads are moving kind of downward, and some of them are moving upward, like this. And you can see that kind of a wave pattern emerges. Probably not going to be very good at drawing this, but we'll do our best. Yeah, something like that. You get kind of a wave pattern on the string, right? Just by moving the beads up and down and seeing an oscillation. So each one of these particular beads, for example this one, it's moving up, and then it's moving down, and then it's moving up, and then it's moving down, and it's going back and forth like this. Each one of them is going up and down. If they're all in the same phase, they all move up and down together, which is quite unusual in real life examples. But most of the time they're out of phase, which means some of them that they're moving up and down at different times, and they're displaced by different amounts based on that phase, right? So let's go ahead and look at the equation. So for a traveling sine wave, the equation looks like this. Y of t, which means the vertical displacement of a particular bead, is A times sine of omega t plus phi. Okay, so we need to define these variables. A is the amplitude, which, going back to our picture, our picture's gone. Nevertheless, amplitude is the maximum displacement of the beads. So if you have a bead on a string or a certain position on a spring that you are oscillating, amplitude is the maximum displacement, meaning the furthest away it gets from its rest position. Omega, or W, either way, is the angular frequency, Typically that's in radians per second, and this is partially controls how fast the wave is oscillating up and down. Then you have time, which in the real world passes at a steady rate, right? 1 second per second. But if you're looking at it in like slow motion or fast motion, or if you're drawing a processing sketch, time can go at different rates, right? Or I guess if you're doing relativistic equations, time can vary. So that's also going to control how fast your wave is moving up and down. And last but not least, phi controls the phase. And there's two important parts of the phase. The sign can be used to control the wave direction. And the magnitude can specify the starting position. So the phase tells you where the beat on the string starts out. If they all start in a different position, you get a more interesting result, because you can actually see that distinct sine wave. Okay, so we're going to have to take this amplitude, angular frequency, time, and phase, and we're going to have to include that in our model for creating a processing sketch to make this kind of wave on a string picture. Okay, so let's switch over to processing sketch and try to make this thing work. Okay, so we have processing sketch open now, and first thing we want to do is define our variables. So we'll use floating variables for most of these, because they'll potentially they'll have decimals. So we'll just cover our bases here. I'm going to set the amplitude at 100 pixels, meaning the maximum displacement for our wave on the screen will be 100 pixels. So it'll go 100 up and 100 down, which covers 200 total. And as a reminder, this is the wave amplitude. We'll also create one for frequency. And I'm going to set that to 0.0314. Whenever I'm dealing with waves, I like to toss in pi or multiples of pi in there. It's fairly arbitrary, and you can kind of tweak that as you want, but that's kind of what I start with usually. So that's I'm calling it frequency for short, but it's the angular frequency, which in the equation was an omega, which looks a bit like a W. But for this sketch, we don't have that many variables, so I'm going to sort of spell out some of them. Makes them a little bit easier to keep track of when you're looking at the equation. Time we'll initialize it at 0. And then we need to define diameter and radius of the beads that we're going to draw on the screen. So again, this is totally arbitrary. I'm going to make the diameter of the beads 10 pixels. And then radius is diameter divided by 2. So we'll set this as an equation with a variable here, so that if we change the diameter to adjust the bead size later, the radius will sort of dynamically adjust to that, and we don't have to remember that we need to change it as well. Okay, for the size of the window, I'm going to make it 900 by 400. So significantly more rectangular than we've been doing before. With a wave, the displacements are up and down, but if we have kind of a wider screen, we can see more of the wave. So that's sort of why I'm making it that shape. Okay. So we're ready to draw. The first thing we want to do is draw kind of a starting position for our string. And actually, let's set the background as well. I'm going to do white on black. It's a good contrast. And actually, for everything that we do in this sketch, I also want to put in the translate. It'll just make everything a little bit less cluttered. I want to translate everything on the wave to the middle of the screen, so height divided by 2. And that goes for our line as well. So we'll go from 0, 0, which means middle of the screen on the left, to width 0, which means middle of the screen on the right. So we're just going to draw a line across the center of a horizontal line across the center of our screen. Remember, we're doing a translation here, so these zeros actually represent the middle of the screen rather than 0, which would normally be the top of the screen. Okay, let's make sure our line is drawing here. Okay, so this is our string that we've drawn. Now we want to put some beads on it, and then we'll figure out a way to oscillate those beads. Okay, so the best way to draw a lot of beads along the line is with a for loop. And what we want to do is our starting position. We want to be 1 radius of a bead, because I mean, if you started it exactly at 0, you'd have a bead that was half on the screen and half off. So it really doesn't matter. But I'm going to start with the first bead showing up completely on the screen. And then we want to go all the way to the width minus the radius. So as we're thinking about moving these beads across the screen, we want to go all the way the full width, but just a tiny bit less than the full width, again, so we don't have a bead hanging off the screen. It sort of stops right there at the end. And then this is an arbitrary decision, but I'm going to do plus equals diameter times 1.5, so that there's a half diameter gap between each bead on the string. You could just get rid of this and leave it as diameter, and then they would just, all the beads would be touching. Or you could do times 2, and then they would be evenly spaced across the screen. I like the times 1.5. Again, it's completely arbitrary. I mean, it's something you can set based on what you want your sketch to look like. Okay, so what we're going to draw is the beads will be represented by circles, which in processing, of course, is an ellipse function. And we want them at an x position based on the for loop. Initially, we'll just put a 0 here to place them in the middle of the screen, just to kind of make sure that we're drawing them correctly. And we'll draw it at diameter, which corresponds to this variable right here. So they'll be pixels. They'll be circles 10 by 10 pixels. That should do it, really. So let's see if it draws them. Yeah, okay, so we have beads on a string, right? And now we want to be able to displace these so that they're moving up and down out of phase with each other, so we can see a traveling sine wave. So how do we do that? Well, first we need to introduce a phase variable. Makes sense to do that right here, I think. And we'll call it phi. Or, yeah, let's just call it phase. And your phase increment can be, I'm going to base it on this radius because I want each of these beads to the phase to shift a little bit as we move across the screen. So I'm going to do x times 0.01. So I want the phase to shift just a little bit each time we move over. I'm making it negative because that will, I believe, if I remember correctly, that will move the wave in the right direction, towards the right. Whereas if it's positive, it moves it to the left. We can try it both ways. Again, the sign is kind of an arbitrary decision for the purpose of this sketch. Okay. Then we want to go in here and control the vertical position of each of those beads. Using the equation we introduced at the beginning of the video, we do the amplitude times the sine of the angular frequency times time. We need to put a time variable in down here as well so that time moves forward, plus the phase. Okay, so this is our maximum amplitude. The sine controls the oscillation. Frequency and time work together to say how fast the wave is moving back and forth, and the phase puts each of the beads slightly out of sync with each other so we can see that sine pattern. And then we need, we'll just have time plus equals 1. You can tweak that to make it go in fast motion or slow motion, but for the purpose of this sketch, we'll just keep it simple. And I think we're in good shape. So let's go ahead and play it and see what it looks like. Cool. So as you can see, each of them is now oscillating up and down. They're out of phase with each other, which makes for kind of a nice picture. And we left the string initial position here so you can sort of visualize it a little bit better, what each bead is doing. And that looks pretty good. So things we can tweak, right? We could tweak the size of these beads. Keep in mind that'll change the phase a little bit because we're basing it on the horizontal position. We can make them quite a bit smaller. Again, it changes the phase a little bit. That looks kind of nice. I'll leave it at 10 for now. We could change the frequency. So, I don't know, let's get rid of an entire decimal place. Maybe this thing will move super fast. Yeah, that looks pretty crazy. And what if we move the decimal yet another time? So we're actually at 3.14. And then we get, right, super crazy. That's moving, it's actually moving really, really fast, but it gives you the illusion that it's moving very slowly. So you can do some really cool stuff by playing around with that angular frequency. You could also change your phase increment here, but yeah, looks pretty good. So let's copy and paste this into, let me make sure I didn't tweak anything where, yeah, still looks normal, into P5. Again, this one should be pretty easy to adjust. We want to change the syntax so that it's, our variables are defined by VAR. The tricky ones are the ones in this for loop. They might kind of be hidden from you. So always, if you're translating between P3 and P5, always check your loops really carefully for variables that were defined inside the loop or down here. The global variables are pretty easy to see, but sometimes these guys down here get a little bit hidden. Remember, these are functions, and we want to create canvas. Background works, line, stroke, ellipse, all these equations should work the same way in P5. And there we go. So P5 is working, the sketch is working. I think we did a good job. So enjoy your waves, and I'll talk to you next time. Thank you. Goodbye.